Hi everyone, and welcome to .NET Conf, Focus on Blazor. .NET Conf is a live, free, online streaming event where you can learn everything there is to know about .NET, your platform for building anything. Last September at .NET Conf 2019, we had 3 full days, 24 hours per day of live streamed content all about .NET from folks both on the .NET team here at Microsoft and also from the community. We had so much fun that we just couldn't wait another year to do it again. So today we're kicking off our first focused .NET Conf event, where we're going to take a full day and dive deep into a specific .NET topic. These focus events will be spaced throughout the year, and you can find all about upcoming events at focus.netconf.net. Now, today's topic is Blazor, and we have a wonderful lineup of speakers and talks covering everything Blazor related. We're going to cover everything from how to deploy Blazor into production today to exciting future areas of investment. My name is Daniel Roth. I'm a program manager on the ASP.NET team. Welcome to Blazor, your full stack solution for building web apps with .NET. Now, why use .NET? Well, .NET is your platform for building anything that can run anywhere. You can use .NET to build applications from the desktop to gaming to mobile and to the cloud. .NET is a mature, general-purpose programming platform that is built to be fast and secure. .NET comes with a common set of innovative languages, tools, and frameworks that you can use to stay productive no matter what type of app you're building. Millions of developers use .NET to get their job done. .NET Core, our cross-platform and open-source implementation of .NET, now has over 1 million active developers using it every month. .NET also has a great open-source ecosystem. We have now accepted over 100,000 pull requests from the community as we've built the platform together. If you contribute to .NET open source, thank you for making .NET what it is today. And we're not done. We've got a lot more to do. Just last September, we shipped the next major release of .NET Core, .NET Core 3. And it is now the fastest adopted version of .NET Core ever. Also last month, we shipped .NET Core 3.1. So if you haven't installed it yet, go get it. .NET Core 3.1 is a long-term support release, an LTS release, of all the great features that we shipped in .NET Core 3, including support for Windows desktop apps with Windows Forms or WPF, support for C# 8, and also support for building full-stack web apps with Blazor. .NET also enjoys a rich ecosystem of partners that build great tools and controls to help you build beautiful apps that are fully featured really fast. Many of these partners also build component libraries and tools for Blazor, like the ones that you see on the screen. These components include powerful components like grids, tab views, charts, and so on. They build them so you don't have to and so that you can stay productive. We were also thrilled to see the .NET Foundation announced today that DevExpress has joined the .NET Foundation as a corporate sponsor. DevExpress joins a group of corporations that are helping to drive the future of .NET both as a platform and its ecosystem. You can read all about that announcement on the .NET Foundation's blog. So what is Blazor? Well, .NET has always had a great story for building web applications with ASP.NET. In a typical .NET web application, you take your .NET code, you stick it on a server, and that code then generates HTML or JSON responses in response to browser requests. But if you then wanted to have any logic that ran on the user's device in the browser, then you had to switch languages and write JavaScript using typically a framework like Angular, React, Vue, or whatever the latest JavaScript framework of the day is. Having to bridge between these two different languages, frameworks, and ecosystems adds cost and complexity and code duplication. Blazor is a client-side web UI framework that enables you to build your entire web application with just .NET. With Blazor, you can build beautiful, responsive, single-page apps, spa apps, without having to write a line of JavaScript. It turns you into a full-stack .NET web developer with your existing .NET skills. Using Blazor, you can write reusable web UI components with C# and Razor. You can share your code across the client and the server. And if you need to still call into JavaScript, like you have that JavaScript library that you still need to use, you can still do that with Blazor through JavaScript interop. Now, how does that work? Well, Blazor apps can operate in one of two different modes. The first mode we call Blazor Server. Blazor Server apps run your components on the server on top of .NET Core. The Blazor Server app then sets up a real-time connection with the browser, typically over a WebSocket using SignalR. Any UI events that then happen in the browser are sent to the server and handled by your components, which then render. Blazor then keeps track of any changes that are made to the UI using a sophisticated diffing algorithm. Any changes are then sent back down to the browser and applied to the live DOM. Blazor Server apps use a very thin client, which can run great on low-power devices and in older browsers. Your .NET code runs on a full .NET Core runtime, so normal .NET features like .NET debugging just work. Blazor Server apps can really simplify your app architecture by eliminating the need to stand up additional APIs or HTTP endpoints. Also, all your code stays on the server. So as you write more .NET code, your app size doesn't grow. It stays the same size. A Blazor Server shipped with .NET Core 3.1 LTS. So it is ready for production use today. The second mode of Blazor apps we call Blazor WebAssembly. Blazor WebAssembly apps run your components directly in the browser using a WebAssembly-based .NET runtime. In a Blazor WebAssembly app, your components are downloaded as normal .NET assemblies along with the runtime into the browser and executed directly in the browser. As UI events occur, they are handled directly by your components in the browser. The components render, Blazor tracks the changes, and then efficiently updates the DOM. Blazor WebAssembly apps have no required server component, so they can be deployed as pure static sites, for example, on GitHub pages or using Azure Static Site hosting. They can also support offline scenarios like you might have in a progressive web app. Now, Blazor WebAssembly is still in preview, and it's not recommended for production use just yet. It did not ship as part of .NET Core 3.1 LTS. But we're actively working on it, and we expect to ship it later this year. And I'll share more about the Blazor WebAssembly roadmap later in this talk. Both of these modes, both of these hosting models, share the same component model. And what that means is that you can use the same components regardless of whether you're writing a Blazor server or a Blazor WebAssembly app. Also, it means that you can easily switch between the two hosting models without much effort. It's easy to get started with Blazor. To get started, go to blazor.net. You're going to need to install .NET Core 3.1. If you want to try out the Blazor WebAssembly preview, you're going to need to run an additional command to get the Blazor WebAssembly template. For tooling, if you're on Windows, you can use Visual Studio. Visual Studio 2019 16.4 includes Blazor tooling support, as well as .NET Core 3.1. So if you have that already, then you should be all set to go. If you're on a Mac, you can develop Blazor apps now with Visual Studio for Mac 8.4, which just shipped last week. If you prefer to use Visual Studio Code, you can develop Blazor apps with Visual Studio Code by installing the C# extension. All right, let's take a look at Blazor in action. All right, so to set up your machine with Blazor, what you're going to want to do is go over to blazor.net. That's the one URL you should remember from today. All right, when you go there, that'll bring you to the Blazor homepage. You're then going to want to click on the Get Started button, which will then take you to this page, and you just follow the steps to set up Blazor on your machine. I've already done that, so let's go over to Visual Studio and create our first Blazor app. Let's create a new project. We're going to select that we want to create a Blazor app. Just look for the purple flame, click Next. That looks like a good name for a Blazor app 1, click Create. And then here you see those two options for creating Blazor apps, Blazor Server and Blazor WebAssembly. For this demo, I'm going to select Blazor Server. Click Create. And now Visual Studio created for me my first Blazor Server project. Blazor Server apps are normal ASP.NET Core web applications. They run on .NET Core. We can see that by looking at the project file. And you can see that this project is targeting .NET Core 3.1. If we look in the startup class, we can see that there's just a couple of lines of code here to set up Blazor Server. Here's where it's adding the Blazor Server services into DI. And then down below, you can see there's also an endpoint being added for the Blazor Server hub. That's the hub that will handle those real-time connections with the browser. This app also has a single Razor page in it, a normal CSHTML file. This over here, host.cshtml. Let's open that up. In this page is where we're adding the Blazor Server script. That's the script that will actually establish the real-time connection back to the Blazor Server hub on the server. And then up above, we're rendering the root component of the app using this component tag helper. And that's all you need in order to get Blazor Server set up in your ASP.NET Core app. You can add Blazor Server to your existing ASP.NET Core, MVC, and Razor Pages applications, and then add components to your existing views and pages. There's no need to rewrite anything. All right, cool. Let's go ahead and get this app up and running. We'll F5 to build and run. Visual Studio will then kick off a build the application, and get it hosted on IIS Express. And we should see a simple SPA-style application. We can navigate around the app using these tabs. We can then use the browser nav tools to navigate forwards and backwards. This is all client-side routing based. Blazor is intercepting the browser navigations and then routing those requests to the appropriate components to then render. On the Home tab, we have some simple HTML content. On the Counter tab, we have a button. Then when we click the button, the count goes up. Normally, this would require JavaScript to make happen because there's no page refresh happening here. But to do this, I didn't have to write a single line of JavaScript. This is all done with .NET and C#. We can see that by looking at the implementation of that Counter tab. That's in this Counter component in counter.razor. Here it is. We can go ahead and set a breakpoint right here in this increment count method. And if we go back to the Counter tab and click the button, boom, there we just hit our C# code, which is handling that UI event. Let's go ahead and let that continue, and we'll go ahead and clear the breakpoint. This counter component, its rendering logic is implemented using Razor syntax. Razor is a combination of HTML and C#. Up at the top, you can see this app page directive. And it's specifying that this component is routable, that it has a route. And the route in this case is /counter. That means any navigations to /counter should end up here. We then have some normal HTML content, and we're using a little bit of Razor syntax here to render the value of this current count field. We then have a button, and it has an onClick attribute, which normally would contain JavaScript, but here we're pointing to our increment count C# method. So every time this button gets clicked, increment count gets called, this C# current count field gets incremented, the component automatically re-renders, and that's what's updating the UI. Pretty cool. On this Fetch Data tab, we have a dynamically generated table of weather forecast data. This tab is implemented by the Fetch Data component, which is in fetchdata.razor. A little bit more going on here, but still looks pretty similar. At the top, we have that page directive again to specify the route for this component /fetchdata. This component is using the @inject directive to inject a service into the component. Here it's injecting a weather forecast service, which is going to get populated into this generated forecast service property. Blazor supports dependency injection, just like all ASP.NET Core apps do. Then we have some HTML markup. Down at the bottom of the component, we can see one of the Blazor component lifecycle methods being used. Here, this component, when it's initialized, it's calling that weather forecast service to get the weather forecast data, and it's setting that on this weather forecast array field. Then up above in the rendering logic, when it's rendering out the table, it's using that weather forecast array and a normal C# for each loop to render each row of the table. It's just that simple. So that's fetch data. The layout of this application, like this left sidebar, this purple sidebar with the tabs, and this little header element up at the top, that's all implemented using a layout component. We can see that in the shared folder. Main layout.razor is the layout component for this app. We can tell it's a layout component because it inherits from layout component base. And it's setting up this left sidebar using this custom nav menu component, and then the main body of the app, including that little header element at the top. It's using this special body property to specify where the content from the different routable components should be rendered. So right here. Where does the layout for the app actually get specified? Why is it this particular layout component? Well, layout is specified using the built-in router component in Blazor, which in this app is being used in the app's root app component. We can see that over here. Here's the app component. It's using the router component. This is the component that will go and find all the routable components in the app and correctly route navigations to those components. And it's specifying also that the default layout should be that main layout component. Awesome. So that's this simple application. We just built our first Blazor app. Now let's take a look at a more realistic Blazor server application. So this is a simple recipe app. Let me go ahead and get this running. All right, so in this app, we have a nice list of recipes with delicious looking pictures. It's got a search text box at the top. We can start searching for recipes. Let's see. Let's search for something with maybe some chocolate. Yeah, OK. We got some Godiva angel pie, some salted caramel 6-layer chocolate cake. That sounds delicious. All right, cool. What else? Maybe we can search for something with strawberries. This app supports, partial searches. So we're seeing strawberries Romanoff, strawberry lemonade, and then straw and hay fettuccine. Apparently this is a real thing, fettuccine with straw and hay, I guess. I don't know. But we can click on the recipe to learn all about it. Here's a recipe details page. We see a summary of the average star reviews for this recipe. Apparently no one's reviewed it yet. Maybe it's because it has straw and hay in it. I don't know. It looks like it doesn't actually have straw and hay in it. I guess that's just a thing that you call your fettuccine straw and hay fettuccine. Down below, we've got the instructions for the recipe, and then some tags, and then a little UI widget for specifying reviews for this recipe. So for example, if we wanted to post a review, let's say like, what should we post? This is great. And it's straw and hay, right? So my horse loves it. 5 stars. Submit. Great. And then maybe another review. Gross. Tastes like grass. 1 star. All right, and as you can see that as we add reviews, they get added to the bottom, and then up at the top, it's calculating the average review. Again, no page refresh happening here. This is all being done in the style of a single page app. OK, so that's this little recipes app. How is this all working? Let's take a look at the implementation. Let's take a look at this home page first. That's in this index component, index.razor. All right, so at the top, we see that page directive again. It's got a route. So this is the component that should render at the root of the app. We're using dependency injection to inject our recipe store into this component. We then have a custom search box component, which is rendering that search box at the top. It's got some normal HTML attributes, and then it's allowing me to, looks like it's allowing me to specify a callback when a search occurs. This search query change callback will then call my search method. All right, then down below, we're rendering out an unordered list of all the recipes, and we're using another custom component to render out each recipe. Down below in the code block, we can see once again, there's one of the Blazor component lifecycle events being used. When this component is initialized, it calls into the recipe store to get the initial list of recipes. And then when any search occurs, it queries the store based on the query provided in order to get the filtered list of recipes. So that's how that main home page is working. This recipe card, that's a custom component. We can see that over here in this components folder. It's pretty simple. It's mostly just rendering out static content. It is using this star rating component in order to render the average star rating for this particular recipe. Here you can also see that we're passing a parameter into this component, the recipe that we want to have rendered in this card, and that's then used above. Parameters are just public properties that are attributed with the parameter attribute. All right. That looks pretty simple. What about this search box component? Well, that's a little bit more interesting. Here's searchbox.razor that implements that component. So this search box is mostly just a normal HTML input. It has a couple of extra things going on, though. It's using this attributes directive attribute in order to add any additional attributes that were specified on the component to be rendered right here on this input tag. So all the additional attributes on the component are captured by this additional attributes parameter and then get rendered right here. That's how we're able to override the default placeholder, which just says search, with our custom placeholder, which says, search for recipes. Okay, and then we have this bind directive attribute, which is setting up a two-way bind between the value of the input and this search query property, which is down below in the code block. So search query is just a normal C# property. And so this is, what's happening here is a two-way bind. So anytime the value of the input changes, then this search query property gets set with the new value. And then anytime that the input is re-rendered, the value of the input is initialized using the value of this search query property. So it's a two-way bind going both ways. And you can also configure which event you want to use for when changes occur on the input. Here we're saying that we'd like to use the on-input event. So every time I type on the keyboard, this bind should occur. All right, cool. So that's two-way data binding. What else do we got? Well, we're triggering that bind on every single keystroke. We probably don't want to do a search with every single keystroke. That would flood our server probably with a whole bunch of unnecessary searches. Ideally, we would wait for a period of time after the user has stopped typing and then do the search. That's called debouncing. And here we can implement some simple debouncing logic for our search box using just normal C#. And you can see that done here. We have a normal timer class, a timer instance, which is from the system.timers. And you can see that in the setter of the search query property, every time the search query property gets set, we stop any timer that's already running, and then we restart it. And then down below, in onInitialized, we're setting up that timer, specifying its interval to be the value of this debounce parameter, which by default is set to 300 milliseconds, but you can change it. And then when the timer elapses, if it actually makes it all the way to the end without being reset due to another keystroke, then it's going to call this search event handler. The search event handler is down here, and every time that search event handler fires, it then invokes our search query changed event callback, which is again specified as another parameter up above. That's the callback that we specified when we use the component on our home page. So every time that timer expires, this callback gets called, which calls my search method on the home page, which then executes the query. So that's how you can implement some simple debouncing logic, all with C# using Blazor. All right, so that's pretty cool. What about the recipe details page? Let's go back to our straw and hay fettuccine. All right, so how is this page implemented? Well, that page is implemented using this recipe details component. Again, it's a routable component. This time, the route actually has a route parameter, so it can capture the ID of the recipe that we want to display details about. It's using a dependency injection to get the recipe store. And then most of this is pretty straightforward. It's just rendering out details about the recipe name, where the recipe came from, and how many servings it has. There's that star rating component again to show the average star rating for this recipe. There's an image for displaying that big banner. And then we're rendering out all of the ingredients for this recipe. Here we're just using a normal C# for loop. to render out each of the ingredients as a checkbox list. And then below we have the instructions being rendered for the recipe. We're again iterating over all of the paragraphs in the instructions and rendering them as normal p tags. We're rendering that list of tags at the bottom of the page so that it's easier to search for our recipes. That's that section at the bottom. Again, using a normal C# for each loop. And then at the very bottom, we have this star rating reviews component that's being used to render this star ratings UI at the bottom. Now, the star rating component and the star rating reviews component, those are custom components, but they're not implemented in the app. Those are actually implemented in a separate class library that's referenced by the app project. They're both in this star ratings project over here. This is just a normal .NET standard class library project that's set up to be able to compile Blazor files as component classes. So the nice thing about this is that because our components live in this class library, we can then reuse them from multiple projects and in multiple applications. All right, so let's take a look at how those components are implemented. Here's the star rating reviews component. It has two parts. So first, it has a form that you can use to post new reviews. We'll go over that in just a second. And then we've got another C# for loop that's rendering each of the reviews that have already been posted. It's putting the star rating for that given review, and also the text from the review, and putting a horizontal rule to separate each of the ratings. All right, that looks cool. So what's up with this form? Well, this form is being implemented using these built-in edit form and input components. Edit form and the corresponding set of input components are a set of built-in components that render normal HTML form and input tags, but with the addition of an edit context that is used for validation. So here we can see that this edit form is being set up to use data annotations for validation. The actual validation rules themselves are specified on the model type. So here our model is this review instance, which is down below. And on the review type, if we go look at it, the review type has normal data annotations to specify that these properties are required and putting limitations on their range and their length. Standard data annotation stuff. We then have that star rating component, so the user can specify what star rating they want to use, and then the input text area component. So if we go back to the form, if we try to submit this form, for example, without any content, validation kicks in, and you saw there was this validation summary component that then displays all of the validation errors for us. As I then use the form in order to provide some review data, you can see that those validation errors automatically start to disappear. This recipe is so-so, and then tap off that, and you can see all the validation errors are now gone. I can now submit the review. And so this valid submit callback only gets called if all of the validation then passes. So that's forms and validation with Blazor. All right, cool. So that's how this app is all functioning. Looks great. Now, because these components, like I said, are for star ratings, are being implemented in a separate class library, that means we can now use them in any app that we'd like. Let's go ahead and try to use them from the app we created previously, the first app that we created at the beginning of this demo. How do we do that? OK, well, first, let's take our star ratings project, and let's go ahead and pack it. So we're going to turn it into a NuGet package with Visual Studio's help. So pack this star ratings project. That'll kick off a build and then create the NuGet package. Great, that looks good. OK, now we should be able to go into the folder for this project in the bin directory. And there's our star ratings NuGet package that we just created. And we can publish this on NuGet.org or wherever we'd like. I've set up a local feed on my machine. I'm just going to copy this package into that feed. And then let's go back now to our original Blazor app. Let's get it up and running again. And where should we add some reviews? Let's add some reviews to this weather forecast page so that people can post reviews about the weather. I mean, people love talking about the weather, right? To express how you really feel. So OK, let's see if we can do that. All right, so let's add a NuGet package, manage NuGet packages on Blazor app 1. Let's browse my local feed, and let's see if we can find our star ratings package. There it is. We'll just install that. and accept all the terms and conditions. Installing the NuGet package. And there it goes. Great. OK, first thing we should then do probably is to add a using statement for the namespace of that package. I'm going to do that in this imports.razor file. Imports.razor is a file where you can specify a bunch of Razor content that will get imported in all the files down the folder hierarchy from that file. So it's a convenient place to put a bunch of common code like using statements. Great. So now we've got our using statement all set up. Let's now go to our fetch data component where we want to add support for reviewing the weather. We're going to need a place to store our weather reviews. So let's create a little list of review right here. We'll call it reviews and a new list of review. Perfect. That's where we'll store our reviews. And then up here at the top maybe right here, let's add a p tag and we'll use that star rating component. And the value of it will be, let's see, reviews. Yeah, reviews dot, and then I have a little helper method, what was it, average? Yeah, average rating, a little extension method that will calculate the average rating of all the reviews in that list. Great, we'll just close that off. OK, let's see if this is working. If we go back to the app, you can see that it's already detected that changes have been made, and it's telling me I just need to refresh the browser. We'll go ahead and do that. And yeah, OK, we're seeing some stars at the top. No reviews so far. Now we need a way to add reviews. So let's go down here to the bottom, and we'll add that star rating reviews component. Get lovely IntelliSense. Great. This asks me to pass in the list of reviews that already exists. So I'll pass in my reviews list. And then we need to wire up this onSubmitReview callback to handle any reviews that get submitted. OK, and I don't have that method for that to handle that yet. Let's go ahead and add that. Let's add a void onSubmitReview method right here. It takes a review. And let's just do reviews.add that review. All right, so we'll just add the review if one gets submitted. And we should be able to say onSubmitReview right there. Perfect. IntelliSense is working. That looks great. Make sure that all the red squiggles go away, and they do. Let's go back to the app. We need to refresh again because we made some changes. Awesome. OK, so we're kind of seeing our form at the bottom. It doesn't look very nice. It's not picking up all the lovely CSS styles that I painstakingly created. Those CSS styles are in the class library project. You may have noticed this www root folder in the star ratings project. If we expand that, you can see there's our star ratings.css file, which has all the nice styles for rendering the stars. There's a new feature in ASP.NET Core where you can include static assets like this in class libraries and then have them get picked up when the project is referenced or when the project is packaged as a NuGet package and that NuGet package gets referenced. So this star ratings.css should be available to my app. There's just a simple convention that I can use to get it. Let's go to the host CSHTML file, the root page of our Blazor app 1, and we're just going to add another link to that CSS file. The convention you use to point to static assets in a library is _content, and then the name of the library, which I believe in this case was star ratings, and then the path to the file under that www root folder in the library. So in this case, I believe it was star ratings.css. And if we save that and go back to the app, F5, and there we go. OK, cool. So we're getting our styles now. All right, so we should be able to post some reviews about the weather. Let's see, what does it look like? It's kind of really hot, kind of warmish. Yeah, it's kind of a mix. Let's say it would be great if the weather could make up its mind. 2 stars. Oh, that's too long, too long. The weather should make up its mind. 2 stars. There we go. And submit that. Great. And then I love variety. 5 stars. All right, cool. And you can see that as we post reviews, they're rendered below, and the average review up at the top, average star rating is being calculated and updated without having to write any JavaScript, no page refresh happening here. There, we just reused our star ratings reviews component in our Blazor server app. Pretty awesome. All right, so that's Blazor in action. This is just the beginning of what Blazor is capable of. To learn more about Blazor and its component model and all of its features, definitely go check out the Blazor docs on the blazor.net site. Work through the tutorials there. We also have a free public open source Blazor workshop that you can work through at aka.ms/Blazor workshop. This workshop consists of a series of self-paced labs that you then use to build this pizza store site with many of our favorite British pizzas. You can see it's a British-themed pizza store site. It's a lot of fun. Definitely go and check that out. Now, Blazor Server is built to scale. Blazor Server can handle tens of thousands of concurrent active users. We test Blazor Server at scale by taking a Blazor Server app and then hammering it with increasing number of active concurrent clients. These are active clients, so they're interacting with the UI, clicking on things about once per second. When we test Blazor Server on a relatively small VM, one virtual CPU, 3.5 gigabytes of memory, it can sustain over 5,000 concurrent active clients at the same time. If you increase the size of the VM to 4 virtual CPUs, 14 gigabytes of memory, it can then handle over 20,000 concurrent active users without any degradation in latency. Now, it can actually sustain more users than that, but at that point, the latency starts to creep up a bit. The main bottleneck for Blazor Server appears to be memory. So these are baseline numbers. Real app behavior will depend on how much your app allocates per connected client, primarily, and then also your client behavior and your corresponding network conditions. But I hope you can see that as a core capability, Blazor Server actually scales really well. If you want to learn all about scaling your Blazor Server apps, be sure to check out Ryan Novak's Scaling Blazor Server Apps with Azure talk later today at 3 p.m. Pacific time. Here are some examples of customers that are using Blazor today. Pivotal is using Blazor for their public SteelToe website. SteelToe is Pivotal's cloud-native solution for .NET. Why did they choose Blazor? Well, they said that using Blazor made it simple to design their website just using C#. Deployed is a startup that's using Blazor to build software for managing statements of work. They wrote their entire app using C# and .NET and just 51 lines of JavaScript. In future Blazor releases, we hope to make that number even smaller. Video Sys Broadcast is a company that makes broadcast TV equipment, like hardware racks for broadcast TV. These hardware racks have a UI panel on the front, and they were able to use Blazor Server to rapidly develop a unified front panel and remote UI for use in a broad range of their products. BST Global is a leader in ERP and business management software. They're using Blazor Server to take their solution to the web. And why did they choose Blazor? Well, it's because it allows their developers to stay productive using C#. Internally at Microsoft, we're also using Blazor. Despite our guidance to that Blazor WebAssembly is not production ready quite yet because it's still in preview, we went ahead and used it anyway. Not recommending that you should do the same. Try.net is an in-browser experience for trying out C# and .NET with just a browser. The code, you just type some code into the browser and then you can click run and we'll run it for you. Originally, this technology, Try.net, used a back-end system, a backend pool of container instances that they would use to take your code, they would compile it, and then run it in those isolated container instances. This backend infrastructure was pretty expensive to maintain, especially considering that most of the time the code was just people running hello world. They were able to use Blazor WebAssembly to instead run the user's code client-side in the browser, and then were able to dramatically reduce the cost of their backend infrastructure. The Blazor community also does lots of awesome stuff. They create component libraries, JavaScript interop libraries, really cool sample apps, articles, videos, blogs. You can check out all things Blazor related in the community at the Awesome Blazor site. That's at aka.ms/awesomeblazor. You can also chat with folks in the Blazor community on the Blazor Gitter. There are lots of folks there all the time to help you get started. All right, so we've taken a look at just a little bit about what Blazor is capable of. Let's now take a look at where we see Blazor going in the future. We envision actually an entire spectrum of applications ranging from web apps all the way to full native applications that you will be able to build with Blazor. Now, we've already seen Blazor Server, where you can build rich, interactive web apps using Blazor and .NET Core. Later this year, we will ship support for Blazor WebAssembly, where you can then run your components client-side on the user's device using WebAssembly. You can extend your Blazor apps to become progressive web apps using existing open web standards, and then enable more native-like features like offline support, or the ability to pin your app to the home screen of your phone, or other OS integrations like having it show up in the Windows 10 Start menu. Blazor hybrid apps are native .NET applications that use web technologies for their UI, like HTML and CSS. We've already shared some experiments publicly of creating Blazor hybrid apps, for example, using Blazor with Electron to build cross-platform desktop apps. Blazor native apps are, again, native .NET applications, but now they're using the native UI elements of the underlying platform. With Blazor native applications, you're no longer using the web technologies to build your UI, like HTML and CSS. You're using the underlying components of the platform. But as a web developer, you get to leverage your knowledge of Blazor's component model and idioms. All right, so where are we at with this spectrum? Well, Blazor WebAssembly, now that we're done with .NET Core 3.1, we've shipped it as an LTS release, shipped Blazor Server as an LTS release, our focus has now shifted completely to shipping Blazor WebAssembly later this year in May. This initial release of Blazor WebAssembly will be based on .NET Core 3.1, and it will then also ship in a future update of the .NET Core 3.1 SDK. Now, because this will be the first supported release of Blazor WebAssembly, it will be a current release, not an LTS release like the rest of .NET Core 3.1. To help make that clear, we will update the versions of the Blazor WebAssembly packages to be 3.2 instead of 3.1. After May, after that release, Blazor WebAssembly will then move into .NET 5 and become part of the normal .NET release train. Here are the features that we have planned for the May release of Blazor WebAssembly. Blazor WebAssembly will support .NET Standard 2.1. It will have support for WebSockets, as well as the .NET SignalR client. It will have full support for debugging, both in the browser and also in Visual Studio. We will support auto rebuild so that you can do fast iterative UI development. IL trimming to keep your app size small. We'll support Brotli compression also to reduce the app size. We will integrate with ASP.NET Core's static web assets functionality. We will support all of the standard authentication options from ASP.NET Core, and we'll of course also add support for localization. All right, what about Blazor Hybrid? Well, we have a couple of Blazor hybrid experimental projects that you can try out. We've already shared previously an experiment for using Blazor with Electron, and you can try that out at aka.ms/Blazor Electron. More recently, Steve Sanderson also shared a really cool new experimental project called Web Window. Web Window is kind of like an Electron Lite. It's like Electron, but without Node.js, which we're not going to be using because we have .NET Core, and also without the embedded Chromium shell. This makes the application much more lightweight, both in terms of size on disk and also memory consumption. You can check out Web Window at aka.ms/webwindow and see how it can be used with Blazor. Exploring Blazor hybrid scenarios is going to be a major theme for .NET 5. And if you want to learn all about what's happening with Blazor WebAssembly and also Blazor hybrid scenarios, be sure to check out Steve Sanderson's talk on Blazor Future Features right after this session. I'm also really excited to announce a new experimental project for Blazor Native. The experimental mobile Blazor bindings is a new experimental project that we just made public today that lets you build fully native apps with Blazor. It includes a complete set of native mobile components for both Android and iOS. It gives you 100% access to native APIs like GPS, Bluetooth, media, and more. You can use existing .NET libraries from your Blazor native application, all done with .NET. You should check it out by going to aka.ms/mobile Blazor bindings. And also later today, Ilan Lipton is going to do a whole session on the experimental mobile Blazor bindings. You should check that out at 1 p.m. Pacific time. All right, here's the schedule for .NET going forward. We shipped .NET Core 3.0 in September and then updated it in .NET Core 3.1 last month in November, on November 33rd, I guess. .NET 5 is then scheduled to ship in November of this year, and we expect to have a major .NET release every year thereafter, with even-numbered releases being LTS releases. We're squeezing in the Blazor WebAssembly release in May of this year, after which the Blazor WebAssembly will then become part of .NET 5 and then continue on as part of the normal .NET release train. For Blazor Hybrid and Blazor Native, there's no committed roadmap yet. These are just experimental projects. The future of those projects, of course, depends on feedback that we get from users like you. All right, so in summary, Blazor is your solution for building full-stack web apps with C# and .NET. Welcome to Blazor. In sessions later today, you'll be able to learn all about how you can build rich, interactive UI components using Blazor and integrate them with your existing ASP.NET Core web applications. Blazor Server has shipped with .NET Core 3.1 LTS and is ready for production today. Blazor WebAssembly is still in preview, but is coming in May of this year. Be sure to try out the new Blazor hybrid and native experiments. And if you haven't already, get started with Blazor today by going to blazor.net. And with that, I'm now ready to answer some questions live. If you'd like to ask any questions about Blazor, you can go to Twitter and use #.NetConf to ask a question, and our moderators will post them and get them all set up, and we'll see what we can do for you.
Okay. We do have some questions, Dan. That was great, by the way. Actually, we have a ton of questions. There's so many amazing questions. Oh, flip my mic. Okay, hold on. Flipping the mic. On. Yes. Okay.
We can hear you now.
We can hear me now. All right,
much
cool.
better.
We actually have a ton of questions. So let's take this one here. It's about security.
Okay.
Hey, .NETConf, if security isn't a factor, what are the pros cons to using DB context directly from a Razor page versus the traditional SPA way of talking to APIs to get data? and why?
All right, cool. So that's really about the differences between the different Blazor hosting models. So if you're building a Blazor server app, remember your code is running on the server. Your components are already there. They have access to the database. If you want to open a DB context connection to your database, you can do that. There's no need to create an API endpoint that you then use to talk to yourself because you're already on the server. So if you're on the server already, you can just go ahead and talk to the database. There's no security concern there. You're already within your secure server environment. If you're building a Blazor WebAssembly app, well, that code is actually running client-side in the browser. So to access resources on the server, then you do need API endpoints that you can talk to. So you would expose whatever data you want to expose through like a normal HTTP API or whatever type of service you'd like to. A common pattern is to abstract away the data access that you do in your application using the service. And then what you can do is you can have different implementations of that service depending on where your components are being hosted. So you could have an implementation of that service that if you're running in a Blazor server app, then it just talks directly to the database. If you're running client-side in the browser, then that implementation of that service can be calling API endpoints, which then talk to the database. And as far as your component code is concerned, it looks exactly the same. That's how you can abstract away those type of hosting model-specific concerns.
Awesome. Cool. All right, how about another one? Here's a couple about roadmap. So waiting for focus. This was actually, he asked the question before it even started.
Got in the queue
so you might have
early.
actually answered this, but first two questions. What is the roadmap of Blazor? I think you did show that, right?
May of this year.
Yeah.
Blazor WebAssembly, I think, is what the.
Yeah, so when's the first stable release of the production environment? Is it a good idea to start work now on a new project using Blazor WASM with the latest version, or should people start using the server mode now?
Great question. So we don't recommend going into production with Blazor WebAssembly right now because it's still in preview. We're still working on it. Things will change, like there will be some API churn in the hosting model, not in the component code, because the component model for Blazor WebAssembly is the same component model that we use in .NET Core 3.1. It actually is the component model in .NET Core 3.1. So that part won't change. But the hosting model code will shuffle around a little bit before we ship. Blazor Server, it's available in .NET Core 3.1, it's LTS, it's ready for production use today. A really common pattern is some customers are starting out with Blazor Server if they want to eventually move to Blazor WebAssembly and then planning to flip their apps over. Blazor Server is also a great solution for many, many applications. A lot of people are being successful with it, so that's something you can do right now. If you are waiting for Blazor WebAssembly, that will release in May, at which point it will then become a supported framework.
Cool. Yeah, I think we still have some time for more questions here. How about this one? This seemed interesting. We're developing a Blazor SPA and are concerned about performance. It will have a large number of on-screen components. Can you explain how we ensure all the components are not reevaluated, Razor scripts run, when a small change takes place?
Yeah, that's a great question. So Blazor's really clever about this. So Blazor actually keeps track of changes as they get made, and will only run the components when they're relevant in the component hierarchy, and also will only touch the DOM when changes have been made to that part of the DOM. Blazor has a very clever diffing algorithm that it uses. So as components render, it keeps track of what was rendered previously and what was just rendered. It calculates a diff, and that's what it actually uses to update the DOM. So from a UI rendering perspective, Blazor is actually really efficient, and I don't envision any issues there. In terms of runtime performance for like your code, like your business logic, Blazor Server is running on a normal .NET Core runtime, so it gets all the performance benefits of .NET Core, which is blazingly fast. Arguably one of the fastest stacks on the planet. Blazor WebAssembly apps are running on a WebAssembly-based .NET runtime. That runtime today is an IL interpreter-based runtime, so it's not the fastest thing on the planet. It doesn't have a JIT. It's not running your C# code as raw WebAssembly. It's actually interpreting your .NET IL on the fly. In the future, we plan to address that runtime performance concern for Blazor WebAssembly using what we call ahead-of-time compilation, where we can take your .NET code and compile it directly to WebAssembly to speed up your app's hot paths. Ahead-of-time compilation is not slated to land for the May release, but it is something that we're looking at in the .NET 5 timeframe.
Cool. Cool, we have time for more questions here. So here's a good one about testing. So how do we test Blazor and do stuff like component tests or integration tests that are possible in, say, React? I think we have a testing session later in the day.
We have a whole talk on
Okay.
this today, so great question. Yeah, definitely check out Ijel's talk later today. I don't remember the exact time, but you can find it on the agenda. Steve Sanderson has put out an experimental project that he put together that has a test framework for doing unit testing of your Blazor components. You can also do end-to-end style testing using components like Selenium. Ijel has his own testing framework as well, where you can write your tests using Razor syntax. He's got a whole bunch of stuff that you'll definitely want to check out if you want to learn about all things testing related in Blazor.
Yeah, God, there's so many questions coming in. I actually lost my place. So there was like a couple in here. I was like, guys, hold on. Because we actually have a few more minutes still. Let's see. How about this one? I just random pick. Can you talk about how Blazor Client will work with Azure AD B2C using JWT for auth? Are there good examples today, or will this be more baked in May?
So in May, we will implement support for all of the different standard authentication options that we use in ASP.NET Core. So that includes using authentication with ASP.NET Core Identity, using authentication with Azure AD, with like organizational accounts, using Azure AD B2C, and also using Windows authentication. The plan initially, I believe, is to use a cookie-based approach. So we will handle the authentication dance with Azure AD B2C on the server and then establish an authentication cookie. But fundamentally, the authentication flows for Blazor apps are no different than what you would do with any SPA-style application or ASP.NET Core application. The only difference between these two apps is that in one case you decided to write JavaScript, and in the other case your code is executing .NET IL and C#. But the protocol flows for authentication remain exactly the same.
Cool, that's awesome. All right.
Actually, on that one, I think Javier has a talk later today on JavaScript interop.
That's right, he does.
And in his JavaScript interop, I know one of his demos is he is taking the JavaScript authentication logic in the ASP.NET Core React template that we use for doing authentication with Identity Server and showing how you can use that in a Blazor application. So if you're curious about Blazor, JavaScript interop, and also authentication, that would be a good talk to check out.
Absolutely. Okay, I actually thought that this one was pretty good right here because we've been talking about the benefits of Blazor, just C#, that's the benefits, right? But what other benefits would you say there is for using Blazor over other popular frameworks like React or Angular, excluding that C# developers are happy?
Yeah. Well, I mean, you can't say that enough, though. One of the great value props of Blazor is that you can now do full stack web development with .NET. You're not having to bridge these two different worlds, having code duplication, write code validation logic once in .NET and then again in JavaScript.
So like JavaScript developers have had with Node.js, basically, right?
Yeah. If you're a JavaScript developer today, you're probably pretty happy because you have a full stack solution. But I think there's also a bunch of just general benefits with using .NET that I think anyone will find compelling, whether you use .NET today or not. Blazor has really great tooling in Visual Studio for Mac, VS Code, so you get great IntelliSense. It's super easy to get started with. You just file a new project and you're already up and running. It's built on the maturity of the .NET platform. You have a stable build pipeline. You've got Visual Studio for tooling. You have .NET Standard as a stable API surface area. It's got a great support policy. So you're really taking advantage of the entire .NET ecosystem when you decide to bet on Blazor for building for handling your front-end web UI needs.
And my favorite, you can take your skills and then you can build anything else with .NET,
That's
right?
true.
Just like going to back to your first slide. So thank you so much, Dan. That was a great introduction to the rest of the day. Fantastic.